This video is going to help you fill out the top of section 4 of your Unit 9 Circles flip book. The essential question for this section, which is titled Circumference Arc Length, is how do you find the length of a circle arc? Be particular, class, on this essential question, I'm going to go ahead and underline this word, the length of a circle arc. Alright, before we start filling out the normal page, down here in the bottom I want you to write these two things. Arc measure is in degrees. It's going to be from 0 to 360 degrees. That's what we've been doing so far in class, measuring arcs or finding the arc measure, and they're measured in degrees just like angles. Now we're going to be switching to arc length. Arc length is in units like inches, feet, millimeters, centimeters. It's like taking a ruler and bending it around a portion or all of the circle and actually finding out the length of that particular arc. So these two things you have to keep track of. Arc measure is in degrees. Arc length is in units. Okay, first section. Let's go ahead and take a look at what I've written here. But before we do that, let's go ahead and put some stuff inside this circle. I think all I want to do on this one is I just want to cover with you again that the radius of the circle goes from the center to a point on the circumference. The circumference of a whole circle, the whole circle, is found with the formula C equals 2 pi r. That's circumference equals 2 times pi times the radius. In class, pi is not a variable. R is a variable. It can be any measure. Pi is an actual number, but we use this symbol to represent it, so it's easier to write out an expression that has that particular number in it. Okay, so let's use this formula to find the circumference. You've done this before. If the radius of this circle is 8 feet, then the circumference would be 2 times pi times r, which is 2 times pi times 8. And now in this case, class, we normally want to show pi at the end of our expression. This is all multiplication. 2 times 8, 2 times pi times 8. We can multiply this just like this. 2 times 8 times pi. It's the same thing. Well, 2 times 8 can be simplified to be 16. So we would normally write this circumference as 16 pi, and then our unit of measure is feet. Now, that's our exact answer. That's our answer in terms of pi. So if I asked you for the exact answer for this circumference, you would write 16 pi, and let's just use the symbol for feet, 16 pi feet. That's the exact answer. If you want to convert that to a decimal, automatically you have now created an approximate number. But many times on test quizzes and worksheets, I'll ask you or let you just give me the approximate number. So let's go ahead and do that. In our calculator, let's go ahead and type in 16 pi and press equal. And now you can see 16 pi is approximately 50.3, so 50.3 feet is an approximate answer. Normally, I'll allow you to write the approximate answer rounded to 1 decimal, but every once in a while I'll ask you for the exact answer, and in that case you leave pi in your final answer. Alright, so that's how to find the length around the entire circle. Now, how do we deal with just finding the lengths of different arcs? So here's our first example. What is the length of arc AB? Well, let's go ahead and create arc AB. So if you want to draw a couple radii, let's go ahead and label some points here. Let's label this A and label this B. Let's go ahead and say that this particular central angle is 88 degrees. And let's say that the radius of this circle is 3 centimeters. So the radius is 3 centimeters. This central angle is 88 degrees. The question is, well, how long or what is the length of AB? In class, we know what the measure of AB is. We already know that's 88 degrees because the measure of a central angle is equal to the measure of its intercepted arc. So let's see what happens when we convert that to the length of the arc. Okay, the whole circumference is 2 pi r, which is 2 times pi times a radius of 3. We can multiply the 2 and the 3 together, and that gives us 6 pi. Our unit of measure is centimeters. So the whole circumference is 6 pi. Now, just for fun, let's convert that to a decimal just to see what that is. 6 times pi is equal to about 18.8. We dropped the 4, 18.8. So let's say that's approximately 18.8 centimeters. All right. Now, how do we find just the length of arc AB? Well, the cool part, class, is we do it as a proportion. And here's how we do this. The proportion goes like this. The first ratio is the length of AB, which is what we're looking for, over the total length of the circumference is equal to the degrees of the arc we're looking for over the total degrees of a circle. So you can see here in this proportion, the top part, the two numbers there, they're just dealing with arc AB. The bottom of this proportion is dealing with the entire circle. I'll use a circle symbol to show it's the entire circle. So this proportion, class, will tell us, we'll be able to solve for arc AB, and that will tell us the length of arc AB. Let's go ahead and work that out now. So we're going to cross multiply to simplify this. So we know that 360 times the length of arc AB, there's my top left and bottom right, is equal to 88 times 6 pi. And we can simplify these two numbers. We can multiply 88 times 6. So let's rewrite this again. 360 times the length of arc AB is equal to 88 times 6 is 528 pi. And the last thing you want to do is we got to get the length of arc AB by itself. So we're going to divide both sides by 360. And our final answer is going to be arc AB is equal to 528 pi divided by 360. Now, if I wrote that as centimeters, that's my exact answer. But normally, I'm going to ask you to now give me the approximate answer. And to get the approximate answer, we'll put this in our calculator. So let's put in 528 pi divided by 360, and that is equal to 4.61. We can round that to 4.6. So it's approximately 4.6 centimeters. Now compare that to the original. Here's our total circumference, 18.8, 4.6 centimeters. That has to be smaller than that because we're only taking a section of the circumference out. All right, there's your first example. Let's do another one. What is the length of arc AC? Well, let's go ahead and label this circle. I'm going to draw a diameter. Let's put a radius here and a radius here. And I'm going to label some points. How about if we make this A, B, C, and D. Let's say this central angle is 60 degrees. This one is 95 degrees, and this one is 35 degrees. And let's say that the radius is 10 inches. So the radius is 10 inches. Now you can tell the difference, class. This is a length measure. These are angle measures because they have degrees in them. All right. Well, first thing we want to do is figure out what the measure of AC is. Notice it's two central angles next to each other. We're going to have to add those together. If we want the length of arc AC, we're going to have to look at the measure of the central angle that makes that arc, and that's AB and BC put together. So the measure of AC is just 60 plus 95, and that is 155 degrees. All right, now what's the whole circumference of the circle? 2 times pi times r, which is 2 times pi, radius is 10. So our circumference is 20 pi inches. All right, now let's find just the length of arc AC. We're going to write it as a proportion, just like we did before. So the proportion is going to be the length of arc AC over the total circumference, which is 20 inches. There's our lengths, and that is equal to the measure of arc AC over the total measure of the circle. So remember, class, the top of this proportion is just regarding the arc AC. The bottom of this proportion is about the entire circle. And now we can go ahead and solve our proportion. So AC times 360. So I'm going to write it like this. 360 times arc AC is equal to 155 times 20 pi. All right, 155 times 20 is 3,100. So on the right, we've got 3,100 pi, and on the right, we haven't changed that. That's 360 times the measure of arc AC. And now we can go ahead and, again, divide both sides by 360 to get arc AC by itself. So the length of arc AC is equal to 3,100 pi divided by 360. Again, there's our exact answer. The length of arc AC is 3,100 times pi over 360 inches. We can go ahead and put that in our calculator and get an approximate answer. So let's move this so I can see it. We've got 3,100 pi divided by 360, and that is equal to 27.05. We're going to round that up to 27.1. It's approximately 27.1, and we've got inches here. So 27.1 inches. All right, last one. A pizza with a 22-inch diameter. All right, let's go ahead and mark that, a 22-inch diameter. Pizza with a 22-inch diameter is cut into 6 equal slices. What is the length of the crust for one piece? So this time, class, I want you to realize that when it says equal pieces, that means every one of them is going to have the same central angle measure and the same arc measure. Well, the first thing we have to figure out with our pizza is what is the radius. We know that the diameter is 22. Oops, I just changed that to red. Oh well, just leave it the way it is. You know what, let's correct that. I want to make sure that you don't think that that red line meant it was something special there. All right. Well, our radius is the diameter divided by 2. So our radius is 11 inches. Okay, let's set up our circumference. So our circumference for the whole pizza is 2 times pi times 11. That's 22 pi inches. Now this problem is easier than the other ones because in this case you really don't have to set up your proportion. If we know the pizza is cut into 6 equal slices, that means that every one of these pieces has the same exact arc measure, and it also has the same exact arc length. So what we only have to do is actually take our total circumference, which is 22 pi, and just divide it by 6, because that's how many pieces we are cutting it into. So this one is pretty simple. That's your exact answer, 22 pi divided by 6. Let's go ahead and find our approximate answer. 22 pi divided by 6 equals 11.52, so 11.5. So it's approximately 11.5 unit of measure is inches. So see the difference here? This one's a little bit simpler, class, because we knew that every slice was the exact same size. On the other ones, we didn't have that luxury, and we had to set up a proportion and solve for the arc length.